Hey everybody, the purpose of this video is to kind of explore what happens when we change the numbers in a parent function that's a trigonometric function. And really the secret here is it's the same thing that happens to any other function when we change these numbers this way. It's just the properties that we describe, like amplitude and period of a trigonometric function, are things that change along with this. That's really the key. So this first is just the parent function y equals cosine of x with a slider on the b, the number multiplied out in front. And we saw earlier that if I change this value b, that this is changing the amplitude. So when the b is 2, the amplitude's 2, b is 3, amplitude's 3, and so on. And this is for a cosine function. It works identically for a sine function. And when that number is negative out front, that's just a reflection over the x-axis. All right, let's make that one. If we change the number multiplied in with the x, so that was a vertical scale change. This is going to be a horizontal scale change, but just like anything in with the x in the function, it's going to be the opposite. So as the a, like so 2x, 3x, 4x, and so on, as that a number gets bigger, the scale change winds up being the reciprocal of what that a is, the opposite. So right now when the a is 4, cosine of 4x, you see the period has been shrunk down. You can count along. There's 4 cycles of this graph from 0 to 2 pi. So from 0 to 2 pi, I see 4 periods, so that period has to be 2 pi divided by 4. And that's the big key there. This next guy right here, so if I have cosine of x minus h plus k, that should sound familiar. That's how we dealt with parabolas. If I start changing what's subtracted in here, so if I subtract away, let's say h is 2, that just moved my graph to the right 2. So 1, 2 to the right. You can see that here by looking at this maximum values at the point 2, 1 instead of 0, 1 for cosine. And then if I change this k value to say -2 or -3, that shifts that value down 3 units. So the point that was usually at 0, 1 is now 2 units right and 3 units down at 2, -2. So none of that should be super surprising, but what's interesting is what happens when we put all these changes in here together. And I'm just going to do one example with you, and then we'll summarize. So the parent function y equals cosine of x is graphed right now. And first I'm going to move it left and right. So if I shift this again to, let's say, 2 units to the right, h is 2, so x minus 2, and then 3 units down. And then now we start playing around with the a and the b. Notice that we've taken this version of our equations up here, cosine x minus h plus k, and we've put the b on the front end of that, and then the a is inside the cosine function, but not just in front of the x. It's in front of x minus h, so it would need to be distributed into it. If I start changing the a and the b now, so your amplitude's going to change. B is 2.9 or 3. That's an amplitude of 3. And then your a value, let's make the period a little bigger. So let's make the a value 0.5. 0.5. So if our a is 0.5, that's actually a scale change twice as big. And so if we look here now, we see our period goes from 2 to 14.566. If we check that out, that's actually a period of 4 pi, twice as big as normal, because the a value is 0.5. This works identically for a sine function. I think the 2 confusing parts that we'll look at in our next example are right here. Inside, this needs to be factored to just be able to look at the numbers and determine what's going on. And then the k value between sine and cosine is the midline of our graph. So we see here from 0 down to -6 is where our graph goes. So our midline would be at -3, which is what our k value is. I hope this helps, and next video we'll look at a quick example.